Section 3.3, lines. Now, what was the how to graph the lines and equations of the lines and parallel and perpendicular lines? Now, let's start with the standard equation of a line. So, the graph of an equation, the graph of the equation ax plus by equal to c, we call it standard form of a line. So the graph of such equation is a line. So how can you graph such equation here? So we know it's a line, so we need only 2 points. If we need 2 points, we can directly draw a straight line. So one way is to find the intercepts of the equation and then draw a line passing through the x and y intercept. So you find the x-intercept and y-intercept, then you draw the line. So that's one way to do it. And also, we can take two ordered pairs. So we can make a table, and it's the x and y, and take two numbers here, take two pairs, and then we can put them in the graph. So it's here and here, let's say, and then you can make the line. So this is another method. So this is also telling us there's another method without using intercepts. Now let's look at this problem here. The example, graph the equation 2x minus 3y equal to 6. And we can find the intercepts. And how do we find the intercepts? For the y-intercept, you set x equal to 0. And then, you put it here 0. This gives you negative 3y equal to 6. And when we solve it, we will get y equal to minus 2. And we get y-intercept is minus 2. And for the x-intercept, we set y equal to 0, and we substitute it in the equation. And then we have 0 here. We have 2x equal to 6, and when we solve it for x, so it will be 3. So x-intercept is 3. So the next thing is we will put these numbers on the y-axis and on the x-axis. On the y-axis, it's minus 2. On the x-axis, it's 3. So then you can draw this line. Okay, and also it's given here. Yes. If you want to write them in ordered pairs, these x-intercept and y-intercept and x-intercept, 0, minus 2, it's here, and 3, 0 is here. You can write them as an ordered pair or just numbers. Let's graph the equation 5x plus 3y equal to minus 15. We can start with the y-intercept. So set x equal to 0 in the equation. And we get 5 times 0 plus 3y equal to negative 15. And this will give you 3y equal to negative 15, and y is equal to negative 5. So we know this y-intercept is negative 5. So minus 5. Okay, on the y-axis. So set y equal to x equal to 0, and then 5 times 0 plus 3 times y is equal. So okay. We'll try to get the x-intercept, sorry. We set y equal to 0. This becomes 5x plus 3 times 0 is equal to minus 15. And then 5x equal to minus 15, and then x equal to negative 3. So this is the x-intercept. Now we can find negative 3 on the x-axis, and then we draw the line. So this is the line. This is the line. This is the graph of the equation 5x plus 3y equal to minus 15. And we have, okay, So far we have seen this type of lines like this or this, you know, and we have some horizontal lines and vertical lines. These are like, so we will call this one as horizontal line, and we will call this type of, you know, lines vertical lines here. So on the y-axis also a vertical line. This y-axis, and any line like any line parallel to the y-axis will be a vertical line. Any horizontal line is parallel to x-axis. X-axis is also a line. So these are horizontal. These are vertical. You see. Now, so what are the equations of such lines? So they have a non-standard form. They have some different form of equation. So an equation of a horizontal line. So if an equation of the horizontal line passing through the point AB is B. So and the equation of vertical line passing through AB is A. So this is the case here. Okay. Here we have A point, A, B point is this. Now, the horizontal line passing through the point A, B is this one here. So this is the horizontal line. So the equation of this one line is y equal to B. You can understand this one from here. So this is A, this is B. But, you know, when you pick any point here on the line, it will be, the y component will be all B. So for this reason, we will write y equal to B. So it means y equal to B no matter what x is. So you don't see any x here. And for the vertical line, so this is, we said, the horizontal line, and the vertical line passing through this point is this one here. So it's x equal to A line. We call it x equal to A line. And this means whatever you pick here, when you pick any point here, its x component will be A. So x is A no matter what y is. So for this reason, you just see x equal to A as a line equation and y is equal to B as a line equation, and you don't see other variable. Now let's look at this example. It says, find an equation of the horizontal line that passes through negative 2, 2. We can easily draw this one and see show this horizontal line. You can visualize it. It's minus 2. It's passing through minus 2, 2. X is minus 2 and y is 2. So here 2, 2, 2 minus 2. And it says find the equation of the horizontal line. The horizontal line means this way, so it will be parallel to the x-axis. So what's the equation? You see it's the y is equal to 2 level, so you can say y is equal to 2. So the line equation will be y equal to 2. And an extra thing, so what is the x-axis, by the way? What's the equation of the x-axis? In the same way, you can say this is y equal to 0 line. So it's y equal to 0 line, or x-axis, they're same. I mean here, but anyway, in this example, the answer is y equal to 2. So this is the case here. Okay, let's do the example 3. Now this time, let's look at the vertical line passing through negative 2, 2, and find the equation and graph the line. I mean, I will go the other way. So I will first draw the line. I mean, then write the equation. So negative 2, 2 is here. And we are talking about a point, I mean, a line, a vertical line passing through minus 2, 2. So it means, so it's a vertical line passing through this point. So if it's a vertical line, then it will be x equal to, so because this here, this is all, the points are here, their x components are minus 2, so I say x equal to minus 2 line. This is x equal to minus 2 line. So this is the equation of the line x equal to minus 2, and the graph is a vertical line. So as you see here, minus 2 is minus 2, and 2 is here. So you see it's passing through minus 2, 2. Now, slope of a line. Now, slope in Arabic, I think it's mail. The slope m of a non-vertical line passing through two distinct points is a measure of the incline of the line, and it's given by this formula. So it's asking the question here. This is how much the line is inclined. You know, this is steep line. This is a vertical line, fully upright and a fully vertical. And now this is a little inclined, and this one is more inclined. This one is more inclined, so this is more inclined. So they have all different they have all different slopes. So each of them has a different slope here, inclination. So how to find the inclination? How to check it or measure it? Okay, in analytic geometry or in our Cartesian coordinate system, the slope of a line can be calculated by taking 2 points on the line. So these x1 and y1, they are 2 points. They are on the line. There are 2 points on the line. So because it says the slope of a line passing through two distinct points, x1, y1, x2, y2. So this is, let's say, x1, y1, and let's say this is x2, y2. So what is the slope? Okay, y2 minus y1. So this will be y2 minus y1. And this will be x2 minus x1. So when you look at this ratio, sometimes in some books it says rise over run, or vertical change divided by horizontal change when you go from one point to the other point. So their ratio is called slope of the line. So let's look at these points, and let's find the slope of the line passing through each pair of points. So this is x1, y1, this is x2, y2, this is x1, y1, this is x2, y2. We will basically use the formula. What's the formula of the slope is y2 minus y1 divided by x2 minus x1. And okay, one other thing I want to tell you here is you can switch them, but when you switch them, you have to switch also this part. So it means y1 minus y2 divided by x1 minus x2. So you see 2, 2, 1, 1, or 1, 1, 2, 2. So this is important. Now, for the first one, x1, y1, x2, y2. This is y2, y1. This is x2, x1. I mean, put them here. Put these numbers here, and you will get 5 over 4. And do the same thing for this one, x1, y1, x2, y2. I mean, you can use the formula here, y2 minus y1 divided by x2 minus x1. We get Another one. Now let's look at the third one. So in the third one, we see a special case here. -3 and -3 here is y2 minus y1 is 0, and x1, x2 is -1, 1 minus 2, it's -1, so 0 over -1 is 0, and the slope is 0. So okay, let's see this line, what type of line it is. It's 2 minus 3, 2 minus 3, and 1 minus 3, so this is 1 minus 3 is also this one here. As you see here, this is a horizontal line, and for the horizontal line, the slope turns out to be 0. So there is no inclination here, there is no slope. So I mean, there is a slope, but slope is 0. And how about this one? So we have an interesting situation here, because when we calculate the slope, it turns out to be undefined. So 7 over 0 is it's not a number, so it's undefined. So what type of line is it? Let's see. 2, 4, 2 minus 4. 2, 4, 2 minus 3. Now look at here, we have a vertical line, and for the vertical line, the slope turns out to be undefined. So we have 3 cases here. We might have positive slope, negative slope, 0 slope, or undefined slope. So if it is 0, it's a horizontal line. If it is undefined, it's a vertical line. So here is another information. So you can also tell the behavior of the line by looking at the slope. Now, for example, from left to right, let's look at the different behaviors of the lines. So let's look at this line. So from left to right, it's increasing. So it's increasing or rising. And this is here, slope. Its slope is 0. I mean, bigger than 0, positive. But when you look at this part here, so when it's from left to right, when you look at this line, it's going down, falling. So as you see here, its slope is negative. It's negative. You can tell, for example, you take 2 points here. You can tell here this minus this, and this minus this. You will see this is positive, this is negative, and then you will get the slope is negative. I mean, when you use the points, you will see it's negative. We take 2 points and see. And if it's 0, we have horizontal line like this, and if we have a vertical line, so the slope will be undefined. Now we have, okay, now let's learn how to write the equation of a line. So we said there's a standard form, and from the standard form we learn how to draw the graph of the line, of a line, and then now we will go back to the equation. If the line is given to us, how can we write the equation? So the equation of the nonlinear line with y-intercept b and with slope m can be given by the equation. So if someone give you the slope and the y-intercept of the line, so these are given, and you can say the equation of the line is y is equal to mx plus b. So it says this. Or you don't have to you don't have to also have slope or y-intercepts. I mean, at least you should have one of them to write it. I mean, and extra, there should be some extra information. Let's see. Okay. Now find the equation of the line whose 2 points are given using the slope intercept form. So let's look at this question. Find an equation of the line passing through the points 2, 2 and 0, minus 2, then to graph the line. There are several ways to do this problem, but okay, I will go with these two methods here. With this method, let's go with the y equal to mx plus b. So if we know the slope and the y-intercept, then I can easily write the equation. Now, what's the slope? Okay, how can you tell the slope? If you know 2 points on the line, then you can tell the slope. So what is it? It's 2 minus 2 divided by 2 minus 0. So this will be 4 divided by 2, which will be 2. So you can tell now the equation should look like 2 slope at 2 x plus b. So how can you get b? Now you can get b by using these 2 points, this pair or this pair, because they are on the line. If they're on the line, they have to satisfy the equation. So you can directly say y, okay, you can directly say these points are satisfying the equation, and then put them in the equation. Okay, let's put them here. 0 minus 2 set. So you say 0 minus 2 is on the line. So put here 0, y equal to minus 2. And for x 0, you got b. So b has to be minus 2. So then the equation should be y equal to 2x minus 2. And you can check, this is the equation of the line. You can check this one by looking at these points here. This point, look at this point. When you put 2 here and 2 here, so it will be, you will have a correct equality here, true equality. Okay, let's see how it's solved in here in the slide. We already solved, but let's see. So it says, first let's find the slope. Okay, it says like minus 2 divided by 0 minus 2. We have plus 2 slope, and the line equation is 2x plus b. And now we find b, so we can put one of the points on the line. So these are the points on the line. So you can use any of them. Like here, I used 0 minus 2. You can use 2, 2. Okay, it's here, 2, 2 is used. Okay, let's see. You put 2 here and 2 here. What happens is you got b equal to minus 2, and then it gives you y equal to 2x minus 2. So we got this one, right? So it's same, like you can use this point, or you can use 0 minus 2. They will give the same thing for sure. So then to graph the line, so it says graph the line. To graph the line, like just graph them and then connect the points. Okay, it's 0 minus 2 is here and 2, 2 is here, and then make a line passing through these 2 points. So it makes the graph of the equation. Yes, one more thing here. The slope of an equation of the form ax plus by equal to c can be transformed to the form y equal to mx plus b by isolating y. So here, what we mean is this. For example, you are given an equation in standard form, a line equation in standard form, and you can change this one to this form. So how can you do it? You can directly say 3y is equal to 5 minus 2x, and then you can also change them. I mean, when you take their signs with them, you can change. So it will be negative 2x plus 5, and you divide by 3, and then you got y is equal to negative 2 over 3x plus 5 over 3. So as you see, it's the standard form here. Standard form changed to mx plus b form, so slope-intercept form. You can always possible to change this type of equation to here. Okay, let's look at this example. Now in this example, it's asking us to do it. So write the equation of the line 4x plus 3y equal to 6 in the slope-intercept form. So slope-intercept form is y equal to mxb form. So then give the slope and y-intercept of the line. So when you write it, so tell us m, tell us b. It says, so we write 4x plus 3y and try to isolate y. So you can send this one to the other side. You get this one, divide by y. So you got here minus 4 over 3 and plus 2, okay? And then here we have m slope, and this is b. We can say it's b. So y-intercept turns out to be, b is always the y-intercept. So b is, y-intercept is 2, and the slope is minus 4 over 3. Let's look at this example. It says, use the graph shown in the figure below to do the following. Find x-intercept, y-intercept, and the slope, and the equation of the line. So first, let's find the x-intercept. The x-intercept is minus 2. And y-intercept is minus 1. And the slope, okay, to get the slope, we can use these 2 points. So these 2 points, we have to write them as ordered pairs. So let's write it. Let's write this point as an ordered pair. It will be minus 2, 0. And this one will be minus 1. No, sorry, 0, minus 1. So then this gives you the point minus 2, 0. And this gives you 0, minus 1. You can use them in the slope. So these are 2 points on the line, and there are enough to write the slope. So y1 minus y2, 0 minus minus 1, divided by minus 2, minus 0, so it will be 1 over minus 2, so it's minus 1 over 2. So the slope will be minus 1 over 2. And it says write the equation of the line. So we know the y-intercept, so m, the slope m is, we know m is minus 1 over 2, and the y-intercept is b, you know, so this is, y-intercept is minus 1, so you can write the equation as y is equal to mx plus b, which is minus 1 over 2x plus minus 1. You remember this is y is equal to mx plus b. Slope interception. When m is given, I mean we found it, and y is given, the y-intercept we already know from the graph. So it's the equation will be y equal to minus 1 over 2x minus 1. You can write it this way. So this here it will be plus minus, it will be minus. So it's the equation. And let's see how it is given in the slides. The slide here. So it says the slope is this, minus 2 over 4, and then minus 2, minus 1, the y-intercept, and the slope, the y-intercept is minus 1, and it gives this one. So we will do the same thing for this problem. Find the x-intercept, y-intercept, and the slope, and find the equation of the line. So we can take, okay, x-intercept for sure is here. This is 1. Sorry, this is y-intercept. So y-intercept is for sure it's 1, and the x-intercept is -2 here. So you can say x-intercept is -2. Okay, let's take 2 points. We can take, you can take these 2 points here, corresponding to the y-intercept and x-intercept. You can say this is 1, 0. No, this is not true. This is 0, 1. Because this is on the y-axis, so this is on the x-axis, it has to be -2, 0. And then by using these 2 points, you can find the slope. The slope is y2 minus y1, and 0 minus -2, so it will be (1/2). So slope will be 1/2, so it means m is 1/2. And b here, we need a b here. B is the y-intercept, which is 1. So the slope here will be 1/2 x plus 1. So we are done with the equation of the line, but I want to remind you something here. So you can use these points. Also you can use other points. Now, for example, I want to use these 2 points here, like this one and this one here, -4. This will be -4, -1, and this is 2, 2 here. Okay, I will use to get slope. Okay, slope is 2, 2. They are on the line, so they are on the line. So we can use them on the to find the slope. So slope 2 minus -4. No, let's start with the y components, right? 2 minus -1 divided by 2 minus -4. So it will be 3/6, which is 1/2. You see, they're same. So you can use these 2 points or these 2 points. Any 2 points on the line will give you the slope correctly. Okay. Now, we have another way of finding the line equation, and this form is called point-slope form of the equation. So point-slope form of the equation of a line with slope m passing through the point x1, y1 is given by this equation, or sometimes if you write it this way, y minus y1. This y is depending on the variable. This is variable, but this one is just a number here. So it's coming from the point. So x minus x1 is equal to m. So either this way, you can write this way, or this way. Okay, we use this method or this form when a point is known and when the slope is given to us. So for example, find an equation of the line that has 1/2 as slope and passes through the point -2, -1, 2. And it says write the final answer in standard form ax plus by equal to c. So we know the slope. Slope is 1/2, and the point on the line is -1, 2. So it says passes through the point. So passes through the point here means this. Okay, so the point is on the line. So according to this formula here, this x1, y1 is here, and the slope is here. Slope is 1/2, so you can directly write directly use this formula here. Y minus y1 is equal to 1 over 2 times x minus minus 1. So this is x1. You know, I'm using the rule here, so this form. So then the next thing is you can get rid of the fraction, and then you can send x to the other side. Okay, let's do it. So x plus 1, multiply both sides with 2, will be cancellation. It's 2y minus 4 is equal to x plus 1. And then I will send x to the other side and minus 4 to this side. So I will go to, I will have 2y minus x is equal to 5. But it says first x, so I can change their places here. So I can write this one in standard form. Okay, let's see how it is done in the slide. First, slope is 1 over 2, and the point is on the line is minus 1, 2. We can use this formula and this writing here, this point slope form, and then y minus 2 and 1 over 2 slope times x minus 2. So when you multiply both sides with 2, we'll end up with this. And the next thing is you can send this one to here and send this one to the other side. You will end up with this. Or you can change their places, or you multiply with minus both sides. You get this one, 2 minus. So you can get this one or this one. You multiply with minus. You can multiply both sides with minus 1. Anyway, so this is the equation. Now find the equation of the line that has a slope 3 over 2 and passes through 1 minus 1, 1, and write the answer in standard form. Slope is 3 over 2, and the point on the line is minus 1, 1. This is x1, y1. This is on the line, a point on the line. And we can write the equation this way: y minus y1 is equal to m times x minus x1. So y minus y1 is 1 here. So this is 3 over 2 times x minus 1. So then it will be y minus 1 equal to 3 over 2 times x plus 1. We can multiply both sides with 2. So we got 3x plus 1. And after doing this, expanding and putting them in the same side, you can get 3x minus 2y is equal to minus 5. So now it's in this form. Let's look at this example. It says find the equation of a line with 2 given points using point slope form. So this is another type of example. So it says find an equation of the line passing through the points 2 to 0 minus 2. So it doesn't give you the slope, and it doesn't give you the y-intercept for sure. Not given. What is given? 2 points on the line. We know 2 points on the line. We only know this one, 2 points on the line. These are 2, 2, and 0 minus 2. So can we find the slope by using them? Yes, we can find the slope. You remember the slope formula, y2 minus y1, or y1 minus y2. divided by 2 minus 0. It will be 4 over 2, which is 2. So we know the slope now. The slope is 2. And now, can we... Okay, we cannot use the y-intercept, but we can use one of the points on the line, because we know the point slope form. So let's take a point on the line. Which one? Okay, we can use this one, no problem. Okay, take 2 and apply the formula. Apply y minus y1 m times x minus x1. So here y minus, this is x1, this is y1. Y minus 2 equal to m is 2, and this is x minus 2. So we end up with y minus 2 is equal to 2x minus 4. And you can write it this way, or you can directly say y is equal to 2x minus, okay, send this one to the other side, minus 2. Or you can, if you want to write the standard form, you can write minus 2x plus y equal to minus 2. You can send this one to the other side, and you can write it this way. They're both okay. They're both correct. And one other thing, you can also use this one here, like 0 minus 2. You can also use this one here, and we would get the same thing. Okay, let's see how it is done in this solution on the slide. Yeah, the slope is found by using the slope formula when 2 points are given. And then we use the slope point form, and then we write the equation. Yeah, that's it. Okay, as a summary, we learned 2 or 3 types of line equations, like ax plus by equal to c, and we learned how to make the graph of this. And we know how to write the slope of the line equation this way. It's called slope intercept form. You know, they are convertible to each other, so you can write it this way, or you can convert this one to this one, or you can write it this way. And we learned how to write the equation this way, point slope form. To write this one, what is needed? Slope needed, and y-intercept needed. For this one, we need a point and a slope, and a point on the line is needed. So depending on, you know, you can use any form depending on what is given in the question. If these two given, you can write this one. If these two are given, it's this way. I mean, sometimes we give the equation this way, and we ask you m and what is m and b. You know, depending on the question type and what is given, you will see what is given, what is wanted. You will check. But this was just a summary of what we learned so far. Now, there are two, we will see two cases, two situations between the lines. We see parallel lines and perpendicular lines. You know, parallel means this. So these two lines are parallel. So these are parallel. And perpendicular lines are intersecting each other with 90 degrees. So these are called perpendicular lines. Now, if two lines are parallel, if they never meet, so here is another definition, like if they don't meet, Like if they do not intersect, you know, then we call them parallel lines. Now, what's the criteria? How can we tell? From the graph, it's easier to tell if two lines are parallel or not. How can we tell from the equation? And this is, we will deal with this part. So from the graph, it's easy, but from the equation, how? So how to understand their parallel? So we will see that. We will see it in a minute. And the two lines are perpendicular if, okay, if it forms four right angles. Right angle means this 90 degrees. Right angles is like, it means 90 degrees. So if we have 90 degrees, so we say it's perpendicular. These are perpendicular lines. So the criteria is this: if two lines are parallel, it means if and only if means if they are parallel, this is true, and if this is true, then they are parallel. So if and only if one statement exactly means the other statement. Okay, one implies the other one. So if they are parallel means their slopes are same. So these are slopes. So it's L1 has slope M1 and L2, L1, L2. These are the names of the lines. So line 1, line 2. This is slope M1 is corresponding to slope L1, the line L1, L sub 1, and M2 slope 2 is corresponding to this slope of line 2. Now L1, so the criteria for being perpendicular is the product of the slopes is equal to -1. So we can answer the questions by checking the slopes. If they're same, lines are parallel. If the product of the slopes is equal to -1, that means these lines are perpendicular. Now let's look at this question here. Let's consider the line L colon 2x plus 3y equal to 6. So it means this line has this equation. So it corresponds to this equation. So it says write an equation of line 1. Okay, we don't know line 1 yet. So, but it's explaining the line 1 that passes through the point -1, 1 and is parallel to L. So in this type of questions, it is important to visualize it. It is important to visualize the situation. So, okay, it says there's a line for sure. There's L. Okay, we don't know. I mean, we can elaborate. I mean, we can use some details about L, but I don't want to do it. So just this is L. Let's say it has 2x plus 3y equal to 6, and write an equation of the line L1. What is L1? L1 passes through the point -1, 1. -1 is here, and this 1 is here, maybe. Yeah, okay. And okay, there's a line L1 passing through this point, and it's parallel to L. So this is L1. It's passing through the point and parallel to this one. So if they are parallel, what do you expect to get? I mean, in terms of slopes. So the slopes are same, right? So it means slope of L is equal to slope of L1. So this is an important information because they are parallel to each other. So here from the information that they are parallel, you can directly say the slope of L1 is equal to slope of L. And the question, how can we get the slope of L? So can we get the slope of L? So from this equation, can we get the slope? So can we get the slope of L? Yes. So if we isolate and write this one as y equal to mx plus b, then you can tell this is the slope. So let's do it then. Isolate y, and we end up with this. So what is the slope? Slope turns out to be the coefficient of x, so which is minus 2 over 3. And now we write the slope of L is negative 2 over 3. But we know that the slope of this L1 is same as the slope of L, so which is minus 2 over 3 from here. So we say the slope of L1 is equal to minus 2 over 3. Right, the slope of L1 is now, let's call it M1, so it will be equal to the slope of L. So then we write the point slope form, y minus y1 equal to M1 times x minus x1. So we know x1, y1 is this point on the point L1 because it says so in the question. Then we can use this one here, y minus y1, M1 times x minus minus 1. So it will give us the equation. So the equation of the L sub 1 is equal to y plus 3x equal to 1. Now, in the other part, it was saying there's a line, there's this L, and there is this point here. Again, it's passing through 1, minus 1, minus 1, 1. And it says this time there's a line passing through this point, but it's perpendicular to, we call it L2. This is L2. It's perpendicular to L and passing through this point here. So how can you find it? So the idea, okay, we need the slope. I mean, the slope of L2. So, but we know minus 1, 1 is a point on the line is on L2. So if we learn the slope, then we know the point, then we can use this formula again, right? This formula. But how to find it? Now we have to use this perpendicularity. So because here, if this is, the slope here is minus 2 over 3. And this is here L2, its slope, let's say M2. We know M2 times minus 2 over 3 is equal to minus 1 because of the perpendicularity. So M2 will be minus 1 over minus 2 over 3. So what does it say here is the slope of L2 is the negative reciprocal of the slope L. So its negative reciprocal is minus 1 over minus 2 over 3. Okay, guys, here, if you have difficulty in understanding what I'm saying is, if you have difficulty understanding me, please go back to the criteria I gave before, because we need to keep them in our mind to solve this problem. If you don't remember them, you will have difficulty in understanding me, because it has to be already memorized. So look here, this is M2, because M2 times M is equal to minus 1, it means M2 is equal to 1 over minus 1 over M. So M is the slope of L, and the slope of L2. We know L and L2, they are perpendicular to each other, we know them. And that their slopes, the relation between the slopes is this. It comes from here. It comes from here. And then we find the slope of L2. Then we have, okay, we can write this the point slope form. We know the slope now for M2, 3/2. And do we know a point on the line, L2? Yes. The point is in L2, so it has to be L2, guys. Okay, so we write the equation for L2. Y minus Y1 is equal to M times X minus X1. So this is the formula we use here, and it gives you that equation. So this is the equation of L2, and this was the equation of L1. Please go back to the question and read it again. Try to see what points you have in your mind, because in this type of questions you have to know what is given in the question and all the relations between the slope and which forms do you have to use for finding the equation. These are important. You have to put everything in order, and you find a solution path. So you have to think about what to do. If you don't have enough experience, please solve some more problems and exercises so that you will have some experience. Otherwise, if this is the first time you see it, it might be a little complicated to see, because when I'm solving